Now, when it comes to sets, one important thing that you should be able to understand on sets is the rules or set laws. And without knowing the rules, it will be very, very difficult to answer questions when they give you. Now, the first thing that you need to know is that when you've got a set A, this A is representing just another set. It has got a complement, and then you get another complement. So such that they become two complement, it becomes a complement complement. This is just the same as A. I think this one we've been talking about it. When you've got a set A, you intersect it with its complement. Now, intersection is what is common. You've got a set A here. What is common? What is inside and outside? Is there anything common or do they meet? Really not. What is inside cannot meet with what is outside. So the intersection of a set with its complement is always an empty set. I can also write this like this. Please don't put a zero there. If you put a zero there, then it's not an empty set. There's an element. Now, if you've got a set union its complement. So union means combine that set with what is outside it. So that is going to give you the inverse set. We can either use E or we can use U. Does it what matters is what they've told us to use in the question. Again, when you've got any set, you intersect it with an empty set. The answer is always going to give you an empty set. Like, what is common between a set and nothing? There's nothing common. So that's why it's an empty set. But if you get any set, you take a union with an empty set. Union means combine. So if you combine something with nothing, it will always give you that same set. If you get an empty set, you intersect it with the union set, you always get an empty set. In other words, the intersection of two sets, you always look at the smaller set. So an empty set is smaller than the union set. That's why it is giving us an empty set. But when you talk about the union of two sets, it always looks at the bigger set. So that would be the set E. Another thing that you need to know is that A minus B means A intersection B complement. So just get the second thing and then put a complement, change the sign here, it becomes intersection. Please, it's always intersection, not union. So from here, when you are shading, of course, simple shadings, we know them. If this is set A and this is set B, the intersection of these two sets, A intersection B, is just this region on the middle. And the union of these two sets, set A and set B, is just everything. Now these things will start becoming tricky and tricky as you get to work with them. Now say you want to shade A minus B. How do you even get to shade it? A minus B. So what does A minus B mean? A minus B means what is in A but shouldn't be in B. So the whole of this set A but should not be in B. So this is just this region. It should be in A but not part of B. This, of course, we know that is the same as A intersection B complement. So we want it should be outside B, but it should be in the set A. So that's the shaded region. But how? What if it changed from being A intersection B complement to A union B complement? How would it change when you are shading? So here is the set A and here is the set B. So remember, you're talking about B complement. So I can first shade B complement. B complement is just everything that is outside B. Now this is not intersection, it is union, meaning combine with A, meaning shade also the set A. So I'm also going to shade the set A, everything in the set A. So that is how you get to shade. So you see the difference between A intersection B complement and A union B complement. So however difficult something might look, this is how you go about it when you want to shade sets. Another thing, some other laws that you need to be aware of. So the A minus B is called the difference law because of a minus. And then you've got commutativity. the law of commutativity or commutative law. So when you're talking about commutativity, it's more like addition. If you say 2 plus 1 is the same as 1 plus 2. So A intersection B is the same as B intersection A. And same, A union B is the same as B union A. But not a subset. A being a subset of B is not the same as B being a subset of A, unless they've told you. Alright, so this is about commutativity. Whether you start with one is the same as starting with the other. The other one you need to know is associativity. This one just relates three things. If you say 1 plus 2 plus 3, it should be the same when you start with 1 plus 2 and then you add the 3 at the end. So here now, if you say A intersection B intersection C, you see we are working with these two together. That is going to be the same as first me working with A and B, and then the answer that I get I intersect it with C. So same way, even if I put a union there, it will be the same. That's associativity. And then we've got the law of distribution or the distributive law. So when it comes to the distributive, it's more the same as when you have got X and then let's say A plus B. You want to distribute X. So this is going to be X times A, that will be XA, and then you get the sign which is here, plus X times B, that will be XB. So same now in this case we are talking about sets. So if you've got A union B intersection C, so take it that there is a multiplication sign here. So you are going to get this A union, you distribute with B. That is going to give you A union B. Then get the sign that is on the middle there, which is the intersection. And then the A union also distribute it with C. So that will be A union C. Meaning that if they've given you something in the, let's say they've given you something like X complement intersection Y, and then intersection X complement intersection, let's say Y complement. So you need to look for what is common between this part and this part. So in this case, you can see that you've got X complement here, of what also X complement here. And also the sign inside here should be the same. So I've got X complement, X complement. So if I have got this, I can factorize out what is common, that is an X, and then I'll remain with A plus B. Same with what I have here, I can factorize out what is common, which is the X complement intersect. So what will remain here is Y. And then we'll get this sign which is on the middle, which is intersect. What will remain here is Y complement. And this gives you X complement intersect. So what is Y intersection Y complement? Who can respond to that? Isaac, Richard. What's Y intersection Y complement?
Did not an empty set.
Yes, that's an empty set. And then what is X complement intersection empty set? It's what? Alright. So it will still be an empty set. Like at the intersection of two sets, you always consider the smaller set. That will be the answer. So it is an empty set. But if it was union here, it would have been X complement. So this is how they're going to ask you to simplify sets. It's just to use the same principles. So apart from this, the last law you need to know here is the distributive law. Sorry, not I'm just coming from writing distributive. It's De Morgan's law. So the De Morgan's, when you've got A union B complement, This is going to be the same as a complement, and then the sign here, please, it always changes. It becomes intersection. Also the b will gain a complement, so both this one and this one gains a complement, but the sign will change. If there was a intersection here, then it becomes union. So this first one I've written is called the De Morgan's law of the union of two sets. Why? Because there is a union here. If I started with an intersection, that's the De Morgan's law of the intersection of two sets. Now we can now do these questions, which are, okay, the first one here. If A, B, C, D are subsets of the universal set E such that E, now they've given us the universal set. Let me write it. The universal set is 1, 2, 3, 4 up to 10. Okay, 1, 2, 3. I'll just put 3 dots there. 9, 10. So the universal set is the set of numbers from 1 up to 10. And then the set A, what have they told us? X is a member of E. So that means X is a member of the universal set such that X is odd. Now, what odd numbers are in this set? Or let me say, what are odd numbers? What are odd numbers?
Odd numbers are numbers that are only divisible by one and themselves.
That is it. Only divisible. Of course, if we say only divisible by 1 and itself, that would be a prime number. So, odd numbers are numbers that cannot be divided by a 2. 1, 3, 5, 7, 9. They can't be divided by a 2. So we need to look for numbers. They should be part of this set, but they are odd numbers. So the smallest is 1 itself, and then 3, and then 5, and then 7, and then 9. So only these are the odd numbers in the set E. And then we go to the set B. Now they've told us that set B, X is such that it's a member of E, and then X is divisible by 4. So what numbers do you know from 1 up to 10 which are divisible by 4? Any that you know?
4 and 8.
Yeah, that is it. 4 and 8. Okay, and then let's go to the set C. The set C, X is a member of E such that the square root of X is a whole number. In other words, what we're talking about is perfect squares. So if you get 1, 2, 3, 4, 5, 6, 7, 8, if you square these numbers, those numbers you are going to get are called perfect squares. So these are perfect squares because when we put them in a square root, we're going to get a perfect number, a whole number. So which of these are between 1 and 10? So from this set, yes, 4 and what? Okay, including 1. 1 is also a perfect square number. So that is 1, 4, and 9. And just you being able to leave out 1 means that even if you work out this question, you get it wrong because you've already left out one element there. And then now we can go to the set D. The set D, X is such that X plus 6 should be a member of E. X plus 6 should be a member of E. So you know this X is part of the universal set, and then if you get that number added to 6, it should also be part of the universal set. So you can start with 1 plus 6, that is 7. 7 is part of the universal set. 2 plus 6, that is 8. 8 is part of the universal set. 3 plus 6, that is a 9, part of the universal set. 4 plus 6, that is a 10, part of the universal set. If you say 5 plus 6, it will not be part of the universal set. So the only numbers we're talking about is 1, 2, 3, and 4. Are we going okay? Or someone is left out just here, somewhere? Are we all cool?
Yes.
Alright. And then from here now, we are talking about A intersection B union C intersection D. So A intersection, we can start with A intersection B. What is a common in A and in B? What is appearing in both A and in B? So we can see that in B we have got a 4, we don't have a 4 here. We've got an 8, we don't have an 8 there. So what is common there is an empty set. So I'll just put brackets there. Like there's nothing common. And then union. This is the union I've gotten, which is here. And then I'm going to get what is common between C and D. What is appearing in C and D? So you people can tell me what are the elements you can see in C and D.
1 and 4.
Okay, 1 and 4. Now, when you combine nothing with something, what do you get? So what will be the union of these two sets? An empty set and that set.
Nothing.
You see?
1 and 4.
All
One and
right.
four.
So 1 and 4.
1 and 4.
Yeah, we need to differentiate intersection and union. If it was intersection, we are looking for what is common in the two sets. It would have been an empty set. But this is union. Union means combine the two sets. So you always get a bigger set. Intersection, you always get a smaller set. All right, now we can look at A intersection D minus C. Now, the first thing we should be able to find, let's first get A. The set A is 1, 3, 5, 7, 9. And then I'll put intersection, which is here. And then I'm looking for D minus C. So D minus C means what is in D but shouldn't be in C. So look at these two sets. What can you see in the set D but is not in the set C? That's D minus C. What can you see? Let's go on. What can you see in the set D but is not in the set C?
2. 2 and 3.
Yes, that's 2 and 3. Just that. And then now we take the intersection of these two sets. So what is common in these two sets? It's only a 3. So that's the answer. Do we have questions? Do you have questions? No. Alright. We can go to this one. Given that x and y are subsets of some universal set U, simplify the following. First one is x intersection x complement union y. If you look at this one, first thing that should come to your mind is what should we do? Now, when you've got such situations, you need to think of the laws that you know: distributive law, commutative law, associative law, De Morgan's law, difference law. So in this case, we're going to use the distributive. So I'm going to distribute x complement to this one and also to this one. So this will be x intersect distributed to x complement, and then we'll get a sign that is here, union, and then the x intersect distributed to y. And what is x intersection x complement?
Empty set.
It's empty set. Good. Empty set. So this is empty set union x intersection y. So what happens when you intersect an empty set with a set? I mean, when you get the union of an empty set with a set.
You get the same set.
Yeah, you get the same set. So it will be x intersection y. If this was intersection here, then the answer would have been empty set. So that would be the answer. Simplest form. If they say in simplest form, meaning you should only have x and y. Not you have got x, intersection x, and another one. No, you shouldn't see x two times. You should only see it one time. That is the meaning of the simplified set. You shouldn't see one letter twice. Okay, we can go to the second one, which is x intersection y. We have got complement intersection x complement union y, and then complement. So the first thing, let's distribute this complement. So this complement is going to go here, and also this same complement is going to come here. So what we are going to have is x intersection y, and then we're going to have two complements. Remember, according to De Morgan's law, the sign is always supposed to change. It becomes union. And then we're going to have x complement union y, and then a complement comes there. And you know, when you've got two complements together, what happens?
They cancel.
They cancel. So just have x intersection y, and then you have got union. We're going to distribute this complement also. So we're going to have two complements on x, then you are just going to have x, and then the sign changes to intersection, and then you are going to have also y complement. Okay, are we okay here? Are we okay? All right, it seems we are okay. Now look at this. Here you have got x intersect. Also here you've got x intercept. So all you are doing is more like you are factorizing. So what is common? The x intersect, we remove it. What we remove remain here is a y. And then we have got this union. And then what will remain here is a y complement. So it's more like you are going from distribution to factorizing. And then this will give you x intersection. What is y union y complement? Let's see.
I,
Yes.
why?
Y?
Yes.
Really, you are sure it's y? Yeah. Have you remembered now, Richard?
Yeah, I do.
Good. So whenever you get a union of a set with this complement, it's a union. Now, what is x intersect union set? What happens when you intersect a set with a union set?
An empty set.
Really? Let me maybe draw so that we see. This is a union set, and this is the set x. What is common between x and e? What can you see both in x and also in e?
X.
It's x. So every time you get an intersection of a union set with a set, is always that same set. So that's why I started by giving the laws or the rules. Okay, let's look at this one. Let the universal set E be equal to R. So what we have is E is R. R is a set of all real numbers. Don't worry, numbers are also a topic. We're going to look at them. And then we've got all these sets. Now we want to find the set A intersection B complement intersection C complement. Now, do you see that it will be a bit cumbersome for us to work out B complement and then C complement and then we intersect them? We can use De Morgan's law. B complement intersection C complement is the same as B union C and then a complement outside. Is anyone left out? Are we all cool with that?
Yes, we are.
Alright. So we can now work it out. Like when you want to get questions on sets correct, don't rush. You shouldn't like you just go you want to find this direct. No. Move it stepwise. So we're going to get the set B. The set B is starting from 5 up to 7. And we're including 5. We are not including 7. And then we're going to get the set C, and the set C is from 2 up to 4. We're including both. Actually, now we are looking for the union of these two sets. This same thing we can see here is the union. If you combine this and this, that will be its own union, you see. Like, union just means get this set and this set, put them together. So these two sets will be the union of themselves. Now we are looking for the complement of the union. Okay, the complement of the union. So what we are doing is come at this point. You can see that 2 is in C, therefore it won't be outside C. And then we'll put an arrow going in this direction. Why? Because this region is not part of the union. And then 4 is in C, so it won't be part of outside C. 5 also is in C, so it will not, I mean it is in B, it will not be part of the sets outside. And then we can join these. Why? Because this region is going to be outside the union, it's not part of the union. And then we also put a dash here, I mean a dot. So for here you can see that 7 is not in B, therefore it will be outside B. I'm going to shade that, and then we'll put an arrow going in this direction. Why? Because we want what is outside the union. So what I've just shaded here is B complement intersection C complement, or B union C complement. So that is it. So we've done with this part. And then now we go to the A. So we're going to get the set A. The set A starts from 3 up to 6. So 3 would be here, 6 is going to be somewhere here. And you can see for the set A we are not including 3, but we are including 6. So we are looking for where these two sets are intersecting. So we'll put there, and then also here. That's where they are meeting. Remember the question is saying and also display on a number line. I can now put them also on the same, now only one number line. The intersection is starting from 3 up to 4, and then from 5 up to 6. Now you can see that 3 is not part of this set A, therefore it cannot be part of the intersection. But 4 is part of both sets, so it will be part of the intersection. Why? 4 is part of this line, and 4 is also part of this, so it is going to be part. And then 5 is also part of both sets, 6 is also part of both sets. And the badness is, if you just leave out, if you just, instead of you shading here, don't shade, even if everything else is correct, the answer will be wrong. So therefore A intersection B complement intersection C complement is going to be 3 comma 4, like that, union 5 comma 6. Okay, so we can have, yes, Isaac, you can go on before we get to Richard.
Are we looking for what's this? You pick the numbers on B and C. Are we not looking for the ones which have the complement? Or am I just confused?
You are really right. I'm the one who made the mistake by not removing this set. Okay, so it's fine. Let me put these two here. Let's get first this one, which is on top. This is where sets become tricky, because if you of not working them stepwise. So we are looking for the complement. So it is from there. Thank you very much. That's very nice. Up to here, and then also from here. Now we are shading this region, go in this direction, and then we want to see where they intersect with the set A. Actually, this point here is 2, because we are looking at the one which is on top. Okay, and then this one is from 4 to 5, and then from this set here is also not a 6 but a 7. Okay, like that. And then we can now get our set A, which is starting from 3 up to 6. We're not including 3, but we are including 6 Okay, like that. So the intersection now for the set A and the set B union C complement. This is the region here. You see how much harm it would have caused because of not following. So this is just how serious these things are. Like what you can see me making mistakes on now are the common mistakes in the exam. So we're not including 4, we're not including 5. That is because 4 is not part of the set here, and also 5 is not part of the set there. Is that okay now? Alright, let's look at this one. Let x and y be two sets. Now I want to show that x complement union y complement intersection y union x complement is equal to an empty set. And I was saying so much funny things. So just work with, just do what is right and the answer will come out itself. So the first thing is, let's get to distribute this complement. So we're going to have x complement, the sign changes into intersection, and then we're going to have y with a complement, of course. And then we have got intersection. Oh, the intersection here is not changing. That is because we are not distributing a complement to this part alone and this part alone. We don't have big brackets, so that's why the sign here is not changing. And then we're also going to distribute the complement here, so it becomes y complement, the sign changes into intersection x complement also. So this is going to give us x intersection y complement intersection y complement intersection x complement. So when we reach at this point, we need to look for what is common in both brackets. Here you've got x, here you've got x complement, so those two are not common. But in both we've got y complement, so those are common. Now just make sure that in both brackets I start with y complement. So according to commutativity law, we can change this, it will be the same. Y complement intersection x is the same as x intersection y complement. And then from here, since the y complement intersect is common in both brackets, we more like factorize it. So that will be y complement intersect. So what will remain here is x. And then we get the sign which is on the middle, intersection. And then what will be in the other brackets is x complement. And this will give us y complement intersection. Now, can someone give me what is x intersection x complement? That's an empty set. That's true. Empty set. Now, what's the intersection of a set with an empty set? Empty set. That's it. Hence, shown. Now, say some other things. So that is how you get to go about it.